Welcome to The Explainer. Today, we're diving into a really fascinating area of machine learning, one that teaches computers not just to predict things, but to actually create them. We're talking about a model's ability to learn the very essence of data and then use that understanding to generate something totally new. So, let's just kick things off with a pretty wild question. We're all used to computers analyzing data, right? Telling us if a photo has a cat in it or not. But what would it take for a computer to just generate a photo of a cat that is completely synthetic, a cat that has never, ever existed in the real world? To even get to that point, we have to back up and ask something even more fundamental. How can a machine learn anything useful without being spoon-fed the right answers for every single thing it looks at? And that brings us to a really key distinction. Now, with supervised learning, the model gets data with all the answers included. Every cat photo is neatly labeled cat. It learns to map an input to the correct output. But in unsupervised learning, there are no labels. There are no answers. The model just gets this huge sea of data and has to figure out the patterns and the structure all on its own. Okay, so if the goal isn't just to play a matching game with inputs and pre-labeled outputs, what is the goal? What kind of new superpowers do you unlock once a model truly understands the deep structure of data? Well, the answer is, you learn to generate. And this is the whole world of what we call generative models. These models learn the statistical patterns of the data so well, incredibly well, that they can then create brand new, totally plausible examples right from scratch. Just look at these. The slide says these cats aren't real, but let's pause and think about what that actually means. The model didn't just copy and paste parts of other cats, no way. It absorbed the abstract concept of catness from looking at thousands of real photos. What you're seeing are completely novel creations, dreamed up from a learned probability model. And this creative spark isn't just for images, not by a long shot. You can train a generative model on a massive library of stories, and it can learn to write its own paragraphs that make sense. It figures out grammar, style, and narrative flow without ever being explicitly taught the rules. It just learns the deep statistical rhythm of language. This ability to create can feel like pure magic, right? So how in the world does a model actually capture the essence of something so it can generate new versions of it? What's the secret? Well, the secret sauce, if you will, is this concept called latent variables. So what are they? Think of them as the data's DNA, or a compressed blueprint. Instead of trying to memorize every single pixel in a million cat photos, the model finds the essential underlying features, the catness, and stores that in a much, much smaller format. Okay, so let's break down how this blueprint actually works. First, you start with your input, say a complex image. Second, the model acts like an encoder, compressing that image way down to its core latent variables. That's the blueprint. And third, and this is the really creative part, another part of the model acts as a decoder, and it uses that compact blueprint to generate a brand new image from scratch. That compression step is absolutely crucial. It forces the model to ignore all the noise and learn only what truly matters. So we've seen these models can generate some pretty amazing new data. But that brings up a really important question, right? How do we know if a model is actually doing a good job? Are the results any good? And how would we even measure that? Well, it turns out we can evaluate them on three key things. First up is quality. Are the generated samples plausible? Does that generated cat actually look like a real cat? Second is coverage. Does the model generate the full diversity of the original data? All the different breeds, colors, and poses? Or does it just keep spitting out a few repetitive examples? And finally, control. This is where it gets really cool. Can we actually interpret what those latent variables represent and use them to guide the creation? Imagine being able to find the variable for fluffiness and just turn it up like a dial to create an even fluffier cat. That's the power of having an interpretable latent space. The power and the quality of these generative models are moving forward at a truly breathtaking pace. And it's really pushing us to think much more deeply about the nature of intelligence and creativity itself. And this quote right here, it absolutely nails it. These models are getting so good at mimicking the statistical patterns of language or images that their output, well, it feels like it comes from a place of genuine understanding. It's really starting to blur the line between just matching patterns and actual intelligence. And that really leaves us with this huge question to chew on. As machines get better and better at creating art, music, and text that is basically indistinguishable from something a human would make, it forces us to step back and reconsider what creativity truly is, and what unique role will humans play in a world where the act of generation itself can be automated. All right, that's what we've got for this explainer on generative models. Thanks so much for joining us.